Hello, everyone, and thank you for joining this month's edition of the Green New York Lunchtime Learning webinar series. My name is Brendan Woodruff. I'm the co-chair of the Green New York Operations and Engagement Subcommittee, and I want to thank you for taking the time out of your day to join us here today to learn about an issue that I think we're all going to learn a lot about. I know I am. It's something that has come up a little bit. You hear the term super pollutants out there. You hear about refrigeration issues, and we're going to get a really good, thorough explanation of it today, which is going to be helpful. A couple housekeeping notes as we get started. Everyone is on mute when you join, so if you do have a question as we're going along, please type it into the chat box. We'll get to all questions at the end. In addition, this webinar is being recorded, and it will be put up on the Green New York website, so if you want to circle back around and find something, or if you want to share it with your coworkers or your family and friends, you're able to do that as well. That will be up there within about a week after this recording today. In addition, a couple other notes here. Earth Week is coming up. If your agency does have plans, please let us know. You can type something into the chat box, or if you have any questions about what your agency can do for Earth Week, feel free to reach out as well. And we do have Green Your Commute Day coming up on Friday, May 15th, our annual day to celebrate reducing emissions from transportation. So with that, I'm going to hand it over to today's presenter. As I said, it's going to be a really good presentation today, and it is Suzanne Hagel from DEC's Office of Climate Change. Take it away.
Hi, everyone. Thanks for joining today. Thanks for the invitation. I am going to start with a big caveat that I am not an HVAC expert. I'm not even an engineer, unlike so many of my colleagues here at the department. I do think a lot about emissions statewide of various greenhouse gases, including the gases associated with refrigerants. And I thought about how to, address my own consumer choices in light of that. And so I'm going to share with you what I've learned in trying to think about how to, change my own behavior in my own life as it relates to these gases. But, feel free to always follow up with me if you have future questions about these emissions or other greenhouse gas emission sources. Sorry, Brendan's teaching me how to advance the slides. So the title today is Climate-Friendly Air Conditioning. I'm going to talk about refrigerants generally, though, because it's the same thing if you're thinking about your household refrigerator and things like that, too. So what I'm going to talk about, and it's pretty brief today, is why are refrigerants so important for climate change and for sustainability in the state from my perspective. And what are some things you could be considering as a consumer of appliances, for example? And then at the end, just give a summary of the tips. I Googled around for some different images of historical household refrigeration, and there are a lot of gems out there. This one was one of my favorites. This is an ammonia-based system, probably from the 20s, called the Icy Ball, which involved once your ammonia had basically had run from one ball to another ball, you would heat it up and force the ammonia back into the icy ball and then put that icy ball in a cabinet, and that's how you'd keep your food cold. And I think that's a great example of kind of older technology. But just generally around the history of refrigeration, obviously air conditioning and food refrigeration has become key to our quality of life and is really one of the major modern innovations that kind of changed our lives. But because of that, it also means that global demand is increasing. This is one sector of greenhouse gases where the emissions are increasing faster than population growth because so many more people around the world are adopting air conditioning in particular, but also food refrigeration technologies. But refrigerants themselves, so the chemicals used to keep things cool, have a long history of safety and environmental issues, and that's not really going away. And we really need to think about how to get the safest, but also the least damaging in terms of the atmosphere for refrigerants that we can, because it's a critical part of solving climate change. But it also, obviously, air conditioning and food refrigeration is a critical component to adapting to the future climate as well. I have a brief rundown right here. This is my perspective of what's happening in this industry from the perspective of a regulator, is that, back in the previous centuries we had kind of natural refrigerants, and this is what the industry calls them as well, natural refrigerants, including like water and ice, but also ammonia, carbon dioxide, hydrocarbons like propane or butane, isobutane. Those have properties that makes them good refrigerants, but they had safety issues or they were difficult to use. And so in the 20s, there are a bunch of new synthetics that started being found, fluorinated gases, that would make really good refrigerants as well, and they were a lot easier, and they were a lot safer as far as direct human impacts. But obviously we found out that those were horrible as ozone-depleting substances, so your CFCs, your HCFCs, and so those started to get banned. In the 1990s, you saw an international phase down and a switch to what are called HFCs, or hydrofluorocarbons. The problem is that we've realized that those are actually terrible greenhouse gases. They're actually more powerful greenhouse gases than most of the old ozone-depleting substances that we've replaced them with. So now we're in this new world where we know now that all those synthetic refrigerants have properties that are bad for the ozone layer, they're bad for the climate. What do? Are we going to go back to natural refrigerants? Or are we going to try to find a way to lower the impact of the HFCs? And that's kind of the two different types of refrigerants that I'm going to talk about today, and kind of what's going on from now going forward is that you're going to see a lot more equipment, both on the commercial side and in your homes, that are either natural refrigerants or new synthetic blends that are blended in such a way to make them less harmful for climate change. Brendan used the word super pollutant. There's a lot of these terms kind of floating around, and I blame the state of California for these terms. There's a technical term that's used more frequently internationally called short-lived climate pollutant, and then now there's this term that came out of actually politicians. I believe it came out of the politicians in California for the word super pollutant. But let's just put into context for the rest of kind of the greenhouse gases. You hear a lot about carbon dioxide, as well as methane. Carbon dioxide is by far the biggest problem. It's in the atmosphere. The current level is higher than it's been in the past 800,000 years. It's at a larger volume by far than any other greenhouse gas. So the reason why we have climate change today is because of carbon dioxide. What happens to us going forward is also a factor of all the rest of the greenhouse gases that are important. And methane is the second largest by volume in the atmosphere, and there are a lot of diverse sources of methane, so it's important. But there are also these synthetic gases that I mentioned. So they're fluorinated gases that were created by man that now exist and that we emit, and they also go into the atmosphere. They also have the same properties like carbon dioxide at kind of radiating that warmth back to the earth. They're actually much more effective at doing that than carbon dioxide, so every greenhouse gas is more powerful than CO2 for the same volume of gas. These are insanely more powerful, so some of them are 20,000 times more powerful than carbon dioxide. Not the gas I'm going to talk about today, but there are a lot of these synthetics that are very powerful. Some of them have very short lives, so they break down really quickly in the atmosphere, and when I talk about these new refrigerant blends that have a lower impact on climate, it's all about the fact that they break down really quickly when they get into the atmosphere. There are other fluorinated gases we're not going to talk about today that once emitted are essentially permanent in the atmosphere. Those are gases associated more with the production of like your new thin TV screens and thin film solar, with semiconductor manufacturing and with installation of electricity transmission lines. But today we're going to talk about refrigerants. So those are a little bit different. There are also other pollutants that aren't gases that affect climate change, and I'm going to mention one right here in a second. So what is a super pollutant? What is a short-lived climate pollutant compared to CO2? So these are both the same thing. It's two names for the same group of gases. The things that they have in common is that they have a very short life in the atmosphere, and there's a lot of international attention on reducing those gases now, because if we get in front of that now, maybe we will be able to delay some of the worst effects of climate change. Unlike carbon dioxide, which once emitted could live in the atmosphere for a century, these are gases that can come out in our lifetime, and so if we can eliminate those sources, maybe we'll affect near-term warming. They're also high, quote-unquote, GWP, so meaning that they have a higher global warming potential than carbon dioxide, and some of them have very high GWPs. So again, if we get in front of these, we have a better chance of kind of delaying, at least, some of the worst effects of climate change. So what are the super pollutants? There's three things. Methane, I mentioned. Methane has a pretty short life in the atmosphere. High volume gas, bigger impact than CO2, a lot of attention on methane right now. HFCs, these are the things we're going to talk about today. These are what's in all your refrigeration products. Also short-lived, high impact. And then the last one is not a gas, but particulate matter, otherwise known as black carbon. Also short-lived, treated as a super pollutant. And you'll see that in a lot of the language, both for state, national, and international climate policy. When you hear short-lived climate pollutant, you hear super pollutant. This is what they're talking about. And there's three things I think you should be thinking about when you're considering your own life, is what are you buying? How are you servicing your own equipment? And what do you do when you want to throw that equipment away? Sorry for my throat. I'm going to talk about what refrigerant might be used in an equipment that you may be interested in buying. I'm not going to get into too much today, but what you should really be thinking about too, are you buying equipment that's appropriately sized for what you need? Because the bigger the piece of equipment, the more refrigerant that's going to be in it. So obviously that's another reason why you'd want to think about that. When we get to servicing, we're really going to be talking about leaks and how to address leakage. And then disposal, it's really about the leakage after you throw something away. Okay, so where are the refrigerants in your home? And ignore the image for a second. I'll get to this image. So the refrigerants are in your household appliances that require cooling and in some cases heating. So your home refrigerator, or any kind of small food refrigeration devices you may have, or wine coolers or ice makers. Your air conditioning, maybe you have window units, maybe you have central air. Those have refrigerants in them. Nowadays, there's also heat pumps, different types of heat pumps, and the heat pump is basically just like an air conditioner, but instead of only just transferring cool air, you're transferring heat as well, or warmer air. You're moving the heat into your house. And we see heat pumps used for, central heating and cooling of your home, but also heat pump water heaters also have a refrigerant in them as well. Also, your car has air conditioning. Or cars that you use, other vehicles that you may use, those have air conditioning, and so those also have a refrigerant in them. And then I have some pictures just from Google, just not to pick on any specific company, but there are also products, any product that has a propellant that's propelling an aerosol, there's a potential that that's an HFC as well as any kind of foam insulation. And it's kind of relevant here because when you buy appliances, those appliances are actually filled with insulation foam as well. So when it goes to the landfill, that foam degrades, and the gas within the cells of the foam are also HFCs, or old ozone-depleting substances. So it's the same chemicals. They're just not, instead of being used as a refrigerant, they're being used for other properties. I'm not going to get into those today, but I just wanted to point out these things here that I have, like if you have a keyboard duster, that's an HFC. If you spray foam, in between, like around your windows, like maybe for a home improvement projects, those are HFCs. Okay, I apologize. This is going to look really scary, but we're going to talk about this graph. There are lots of these graphs online right now, and I just picked on one equipment manufacturer, Danfoss. Lots of the equipment manufacturers have these on their websites. There's lots of really great presentations online from some of the companies that represent the manufacturers, trying to understand what's the future for refrigerants. And the reason why I'm going to show you this is there's a couple things. So on the y-axis over here, it says GWP. So that's the impact by volume of a gas compared to CO2. So the high numbers over 4,000. That means that that refrigerant or that chemical has or blend has an impact on the climate that's over 4,000 times that of the same volume of carbon dioxide. So that's one thing to consider. The x-axis here, the density, is that the manufacturers are used to, for example, using a refrigerant with a certain kind of property for a certain type of equipment. And so they're looking for replacements that have the same properties because that's less of a design issue for them to find a new alternative. So that's why they have that breakdown at the bottom. On the legend, you'll see some things that you should start picking up on, is that they're going to break these things down based on whether or not they're flammable or not and whether or not they're toxic or not. So obviously that's an issue for us. As you're going to see some of the new alternatives kind of bring in some of those other undesirable properties. I have some arrows here just to show you if you have a car, if you drive a car, if you sit in a car, that car is right now being air conditioned with something called 134A. That is a straight HFC. These other ones are blends, but 134A is a type of HFC. That is blended into actually a lot of these other ones that are listed here right now. Your home refrigerator probably has one of these things here at the top. R22 is actually the old ozone depleting substance that's now being replaced. And then there's these other blends, high GWP, basically. And then your home AC, your central AC, your window units, those are probably R410A. Heat pumps today going into people's homes, that's R410A. And don't worry, I don't expect all of you to remember this. We're going to come back to it, tips at the end, too. And so here I've added, or I've revealed some of the new lower GWP options that are coming out. As you can see, there's a lot here, but a lot of them are red, and all the reds mean mildly flammable, highly flammable, or toxic. And the main one that's toxic down in the corner under others, if you see NH3, that's your ammonia. So that's the issue with ammonia. It was a great refrigerant. It's pretty dangerous to humans, though, so it can only be used in certain types of instances. If you live in a multifamily unit or in an office building, or if you go to an ice rink or a supermarket, like those are the places where maybe ammonia could come back into use. Above that, I got CO2, and I got an arrow there because CO2 is coming in as a pretty common refrigerant in the EU and Asia, less so here so far. I have an arrow next to something called R32. You're going to see that later. That's actually already on the market in household air conditioners. So that is a lower GWP option than that R410A. So I'm going to show you that. Some of the other arrows, I got an arrow to R290 and R600A. Those are your hydrocarbons, so that's isobutane and propane, and they're really important for home refrigerators, so I'm going to mention that in a minute. And then I've also got, I wrote in some extra text, R1234YF, hard to remember, but you're going to see it in a minute. Okay. So when you say flammable, how flammable are we talking about? Obviously, that's kind of scary to think that you'd be introducing new sources of flammability into your home. But actually, for it to make it into your home, it has to be pretty rigid safety standards. And in fact, our safety standards and building codes are more strict than the EU and Asia when it comes to your household appliances, as well as the stuff that's in our supermarkets and things like that. So just as a point of comparison, I've got over here a picture of a kid. This is from a company that's actually selling refillable propane containers for camp stoves. That's what this picture was. He's holding a canister, just like the Coleman canister. I'm sure many of you have experienced these or handled them. It's about a pound of propane in those canisters. So it's about 450 grams of propane. If you went out and bought a refrigerator today with R600A, it's more like 60 grams. So it's a lot less than what people already feel safe handling in their home. If you get into smaller equipment, eventually I think when you start seeing hydrocarbons come into the U.S. market for like a window AC unit, it's going to be much, much smaller. If it's flammable or mildly flammable, the key is it's at a much lower volume than you'd expect. And it's actually a much lower volume than the other refrigerants because of the properties of hydrocarbons. They're like excellent, very efficient refrigerants. The difference between flammable and mildly flammable is we're all used to flammable stuff like propane. Mildly flammable are these new blends that I mentioned, the new synthetic blends that break down really quickly. They're not, if you impact them, they're not going to explode. It's like having another log in your house, I heard someone describe it as. So the building codes and the safety bodies, they haven't quite figured out how to treat these things. So they're treated right now as being mildly flammable, and they have a lot of restrictions still in our building codes on them. Okay, so what should you look for? So it's a picture of the side of an air conditioner I pulled off of the internet. Notice that says R32, so that's one of these kind of mid-range or lower GWP options than what you would otherwise have. So if you were going to go buy a window unit today, you could look for R32. It's really hard to find, though. In my experience, it's hard to find out what the refrigerant is. Like, you can't just go to the Home Depot website or Lowe's or something and expect to find the refrigerant that easily. You could look for clues on the packaging, and I'm going to show you a picture of that next. You can try looking at the manual or the spec sheets that come for the appliance. You can also take the model number, maybe of an item you're thinking about buying, and do an internet search. And sometimes if I search by, use the term GWP, you're more likely to have someone tell you what the refrigerant is. If it's not listed, you absolutely have to assume that it's one of the blends I mentioned earlier. But we found this summer when we were buying a window unit for a friend of ours that there's some interesting clues to tell you what may be in it. And these are two, again, not picking on any specific company, these are the same company, very similar sized air conditioning window unit, two different boxes. One of the boxes says non-ozone depleting refrigerant. That's an indication that they've switched to HFCs. So that's a guarantee that that refrigerant, if that's all it says on the box, that that refrigerant is R410A, it's a HFC or it's a greenhouse gas. On the other hand, and this may seem counterintuitive, if it says risk of fire, refrigerant is flammable, that's excellent because that means it's one of these ultra low, one of the best options that we're going to have for equipment. So I hate to tell you this, but it's a good sign for sustainability if you're buying something that says flammable on it. So what about your car? So I have a picture actually of our family car, which is a Chevy Bolt. My husband has a terrible phone, and this is the picture that he took of under the hood of our car. And I think many of you, if you're DEC employees, you probably know who I'm talking about. But pre-1994, they used the ozone-depleting refrigerant. That means any car that's on the road right now, and I know our fleet has cars that are older than 1994, the refrigerant that's in them is this ozone-depleting refrigerant, and that is the refrigerant that will be in that car as long as it's on the road. And once it's thrown into a scrapyard, if the refrigerant isn't reclaimed, that's what's going to go out into the atmosphere. After 1994, they switched to the HFC 134A, very powerful greenhouse gas. Any car made after 1994 has 134 in it. It will have that in it for the rest of its lifetime. And nowadays, there are some models that have a new, very low GWP blend, 1234YF, which is going to be really hard to remember. And then I think Dahmer is actually switching to CO2. But it's not that easy to figure out what would be in a car. It's not all models from any one manufacturer. It's like a selection of models. I actually thought our car had 134 because that's what the internet told me should be in it. But obviously, Nathan took a picture, and that's not what's in it, which I'm happy to hear. But if you were going to go look at a car, you could if you're picking between models, that's maybe something that you'll find. The biggest thing, though, with cars and with any existing equipment is really servicing and disposal. So if you have a package, what they call a packaged appliance, so it's an appliance that was sealed in the factory, like a window air conditioning unit or a refrigerator, they surely shouldn't leak. They shouldn't be subject to issues that would lead to leakage of refrigerant. However, your central AC system or a heat pump system, and even your vehicles, they are likely to leak throughout their life, from my understanding. And the more refrigerant you're talking about, and particularly the more the refrigerant line, the greater the chance of leakage. And what I mean by refrigerant line is some of the new heat pump systems that you may use for home heating and cooling, they're actually running refrigerant through the whole building. So that's a lot of points of potential compromise, and also a lot more refrigerant for the size space. The trick is to replace the equipment. If you have something that's leaking a lot and it can't be fixed, it continues to leak, it's time to replace that equipment if you can. And just keep in mind, the car AC is no joke. If your car AC isn't working and you go to Valvoline to get it fixed, they're just going to put more refrigerant in it, and that refrigerant is going to leak out as well. So keep that in mind. Interesting, and this was supposed to be a pun just because you can, and we're going to talk about DIY cans. The only legal refrigerant that any consumer can handle is for your car, to recharge your car's air conditioning unit. This was legal for ozone-depleting substances. The picture in the middle is an ozone-depleting substance. You can buy these at Walmart. You can buy them anywhere, and you can fix your car with it. But again, it's just leaking into the atmosphere. It's not an actual fix of a source of leakage. And the cans themselves, depending on how they're designed, you could be inadvertently leaking stuff into the atmosphere. So when you use these things, if you have to use these things, just keep in mind you're handling a very powerful greenhouse gas that is almost completely unregulated and unenforced. And the last thing I was going to talk about was disposal. This is a picture actually from a refrigerator, I think it was a refrigerator manual, just reminding you that your refrigerator may have ozone-depleting substances in them, and that you may be subject to local, state, or federal law and how those things get disposed of. And what we hear from the industry is basically very little enforcement. When you throw something away, it goes to get scrapped. People will just cut the refrigerant line and let the refrigerant leak, or they'll look like they're capturing it and reclaiming it, but really they're going to let it go because there's no value to reclaimed refrigerant right now. And I say it's the law, sort of, because until last year, HFCs were going to be included in the federal laws, also covered ozone-depleting substances. That is now, as of, I think, a couple weeks ago, officially going to be rescinded. So there is really no restriction right now on the leakage of HFCs. So it's on the consumer for now to make sure that those things are being properly captured. And one source that you could go to is there's this RAD program, which is a voluntary program that the EPA put together. You can see what companies that committed. I believe Home Depot and Sears are on this list. So they're committed to take these appliances back and make sure that the refrigerant is being properly reclaimed. And I just put a screen capture here from their website. They have lots of other information. For example, their concerns around that foam insulation that's in appliances. How's that getting reclaimed? How are the refrigerants getting reclaimed? How are the metals getting recycled, and how are other units being resold versus being recycled? So I think it's one source to look at is the RAD program to give you some additional guidance. And again, that's just www.epa.gov/RAD if you want to look at that program. Okay, so I was going to go over the summary a little bit. I think in general, if you can replace old appliances, because chances are when we bought our friends a window unit for their home in Ithaca, it's because they had a giant old air conditioning unit that was filled with a horrible ozone-depleting gas. It was probably 30 years old. So it's good to replace stuff if you can. The new stuff's also way more energy efficient. And there are a lot more options, I think, for finding something that's the right size for the space that you're trying to cool, for example, or refrigerators that may be the right size for your family. Don't let them leak. If they're leaking, if they need lots of servicing, it's time to find a new piece of equipment if possible. And then, of course, the big thing is, like, do your research if you can. And I just want to give some just quick tips here. Avoid R12, R22 are the old ozone-depleting substances. I named the common replacements that are out there now. If you're going to go buy a new AC unit, look for that R32 because I know those are out there and they're a better choice. If you're buying a new refrigerator, if you can find out if it has R600A, I think that's the common one now, isobutane, for home refrigerators. That's a much better choice than the other refrigerant. And there's going to be new stuff coming on the market. I think the next few years we'll see a lot more options here in the low GWP space.
Mm-hmm.
That's it.
That was fantastic. Thank you so much, Suzanne. And we're going to get into questions here, so if you do have any questions, please type them into the chat box. I see we've got quite a few here to begin with. I'm just going to start with today's quiz. I hope you are all going through and remembering the types of refrigerants that were out there. Just kidding. But one of the things that kept going through my head as Suzanne was going through the presentation today was how air conditioning and refrigeration is really one of those negative climate feedback loops that we're seeing, where as temperatures get warmer, we have more of a need for refrigeration and for cooling, and that's meaning more energy use, more greenhouse gases. You know, a lot of these refrigerants that have a high GWP are getting pumped out into the system because of the fact that we're experiencing the warming, and especially I was thinking with the car air conditioning, that was one of the big ones. So the first question I've got for you here is, you mentioned a lot of aerosols is having things. What about non-stick cooking spray? I don't want you to ruin the kitchen for me.
I don't know officially what. So one thing that happened when they were doing the conversion away from ozone-depleting substances is actually a lot of those manufacturers just went away from these types of propellants in general. A lot of them are now what's called not in kind, so they didn't go to another synthetic fluorinated propellant. They went, for example, hairspray started using pumps instead of a aerosol spray. So I don't know. But it could be that it could be something completely different that's used in any one example. And the aerosols have been transitioning away for a lot longer, so they're much less of a concern than the refrigerant piece. But just wanted you to know that there are still things that you can buy that have HFCs in them.
And for an alternative as well with nonstick cooking spray, if you are concerned about that, is they do make those kind of pump bottles where you can put olive oil or any kind of oil in there, so you can avoid aerosols altogether. So the next question we have here is regarding kind of some new technology that's come on the market recently. Is there's some AC units that freeze water for ice at certain times to try and shave the peak demand. So during the heat of the day, instead of it running at peak times, you know, it's able to use the cooling from the ice, like at 4 o'clock in the afternoon or something like that to lower demand. Is that something that your office has looked into? Do you have any, you know, kind of insights on the refrigerants they might be using?
I assume it's the same refrigerants that you're seeing right now. I mean, one thing to consider, and this is an alternative with some of the bigger heat pumps for multi-floor buildings, is there may be a need to go back to hydronic. So if you live in Albany, in downtown Albany, you probably have either radiators or baseboard heating, and those are water moving through your building. So you'd use a lot less refrigerant. Instead of running refrigerant through a space, you were cooling water or some other fluid and running that through the space. And so it's not exactly what you're talking about, but there are ways to maybe lower the amount of refrigerant because you're actually going to be cooling something else, and so somewhat related.
So the next question here is, a lot of times when we're looking at waste reduction, you look for a product that might be higher quality. It might last longer. It might be a little bit more expensive. So with refrigeration units, when we're looking at kind of the leaking issue, if you're looking for something that's a higher quality product, is the coolant less likely to leak in a higher end model than something else?
I don't know. I'm not sure if there's a difference there. What I've heard in terms of vehicles is moving to these different, like moving to CO2 or moving to the new blends. Those are actually a lot less prone to leakage just by design. So we may actually overall, once we make that transition, have a lot less leakier systems, which would be cheaper for the consumer because they're not going to have to be constantly replacing the refrigerant.
Yep. And kind of a follow-up question with that, for most refrigerators and other kind of big, you know, say home unit-sized ACs, is there a way, if it's leaking, to replace the kind of coil in the leaking, or do you have to just scrap the whole unit?
They say that some of the refrigerants are quote-unquote drop-in. But I've gotten the impression that that's not necessarily the truth. You need a new system. You definitely should never put propane in a system that was designed for something else. But I think between the lubricants and other areas of design, you can't just replace it with something else yourself, not safely.
Yeah. The next question here, if they do reclaim the refrigerant, what do they do with it?
So presumably you could clean it, and then there's a market to resell that. There's also a lot of interest in states creating programs to destroy refrigerant. So basically drive the price up for those refrigerants over time by minimizing the amount that's still out there. And I think that would work in cases where we're no longer producing or importing refrigerant, like with the ozone depleting substance. I'm not sure what impact that has for the stuff that's still being produced. But yeah, so either they're cleaning it up to resell or it's getting destroyed.
So once these do get into the atmosphere, hopefully they're not going to going forward, but can you explain a little bit about how they break down and if there's any kind of toxics issues associated with that?
That's a great question. I mean, I think that's just that they have weaker bonds, and so the molecule breaks down more quickly. But the toxics issue is a real thing because people are worried that we're just introducing yet a new family of fluorinated gases, and there's going to be an environmental cost for that down the road. And I think there was a lot of debate around that in the European Union for the policies called the F-gas policies that are kind of driving down the use of these chemicals. I think there's a lot of work there that you could read about. And that's why, for example, Dahmer is going to CO2 instead of the new synthetic blend for cars because of that concern about future environmental problems.
So the next question here, if you do have a new heat pump, is there a way to check for leaks other than waiting until it's a problem?
Yeah, there actually is. I don't know a lot about it, but there are ways that you can check for leaks. They're like, the old style of finding leaks where you put soapy water on something and you see if the bubbles form. There are things like that. I think there's also just more higher tech kind of ways to see if something's leaking. I would talk to the person, though, who installed your equipment as well for assistance on identifying if there's leakage or if you get it serviced. And ask them if they're putting more refrigerant in it and then get help finding out how to fix that problem. If you email me or Brendan, though, I can share with you more information on kind of like the different ways to look at leaks.
The next question here, is Nathan's phone a pre-1994 model?
Yes, very much so.
And guessing from the person who asked that, theirs is as well. So if you do have a question, we're still taking them. Please type them into the chat box here. We have one person who did just join us. Just to let you know, this is being recorded and it will be placed on the Green New York website afterwards. That'll be up probably within a week. So you will be able to watch it then. We have another comment that came in. I can't believe I just learned about these lunch and learns. So fantastic. Every New York State employee should be required to watch them. I did not plant that for the record, and I do agree with them. So please do share this with your coworkers and others, because I think especially today is really fantastic and valuable information that I haven't seen in many places. So if you do have more questions, please type them into the chat box here. We do have a little bit more time to take them.
Yeah, I just want to say one thing, too. Again, I'm not an expert. This is just stuff that I've been trying to figure out for myself. I have found the manufacturers to be incredibly helpful. So if you have a question about something you're thinking about, I think you should feel free to, reach out to companies and ask them for this information. And the companies are incredibly supportive of policies to switch to the cleaner. They actually want more rules. If you've been tracking what's happening at the federal level, it's the manufacturers that really want to see everybody switching to cleaner alternatives. So don't just, I am not an expert. Anything that I said today should be taken with a grain of salt. But yeah, I think it's good to reach out to the companies, too.
And the next question we got here, do you have a sense of the cost differential between low GWP and higher options and how it may translate to consumer prices?
Yeah, I think in the cars you wouldn't notice a difference. It's just the, the manufacturers are switching, but you're not going to know the difference in price. The household AC units, I don't remember there being a big difference in price. But when you get your refrigerators, I do think right now some of the ones with the hydrocarbons or the R600A may be slightly more expensive, but I've not done a full cost comparison.
And just a reminder here, if you do have any more questions, please type them into the chat box, and we will get to them. Just as a reminder for folks, our next Lunchtime Learning webinar is taking place on April 14th, so hopefully you can finish your taxes up and join us. It's going to be on water conservation, so tips that you can take around the home and around your life on how you can conserve water. Not seeing any more questions here, so Suzanne, any final thoughts?
No, I just really appreciate everybody joining and being interested in refrigerants, because there aren't that many people who are interested in listening to me talk to them about refrigerants. So, no, it's great. And please feel free to reach out to me or my office or Brendan if you have any follow-ups.
Yep, and if you do need our contact information, please type it into the chat box and we'll get it to you. Thanks a lot, everybody, and we'll talk to you soon.
Thank you.